Good afternoon, ladies and gentlemen. Very warm welcome to the session. I'm very impressed with the number of people here, actually. I can ask a question. How many of you had problems with Kerberos? Oh, dear. Okay, so in this session, which I believe is actually a very important session in terms of keeping your infrastructure secure, I want to go into how Kerberos works, how you can do delegated administration, what's the difference between the 2000 version of delegated administration, what constrained delegation does for us, and finally, what protocol transitioning does for us. And if you allow a web developer to do some protocol transitioning in their app, or somebody writing you a service of some kind allowing protocol transitioning, it's potentially very dangerous, and you need to think it through very, very carefully indeed. And I want to actually go through that whole process. The other issue, anyone have problems getting a web app running with Kerberos? Okay, there's a few little mysteries around that as well, which I want to cover off. So as soon as actually, how many of you got SharePoint? Lots. You notice Microsoft, you've got Negotiate and you've got NTLM. They did that for a reason. As soon as you go to Negotiate, it tries Kerberos first. And if you run a web app pool, right, but you don't configure it properly to run with Kerberos, you break SharePoint. And that's why you choose NTLM, because it works, right? So we've got to find out what's going on there. So a few session prereqs. Understanding of Windows authentication and authorization. Active Directory itself, user privilege and tokens would be useful, and of course, a bit of IIS configuration. So what we're going to cover off today is, first of all, I want to just do a very quick intro to authorization and authentication. And then I want to look at sort of keys to success. How do we succeed in getting to where we want to be? And then looking at sort of Kerberos in a nutshell. I'm going to give enough information about Kerberos so you can troubleshoot. All right? There's certain things you need to know about Kerberos. One of the best friends with Kerberos is the network monitor. So if things aren't working, we need to know enough about the protocol to actually do that troubleshooting. Delegation, and then good old service principal names. All right? Exactly what do they do and where do you configure them? All right? And when you're doing delegation, exactly who is doing the delegation. Look at the constrained delegation that comes out. We'll then go on to protocol transitioning, and we'll look at how we transition from maybe NTLM or a different protocol to Kerberos, and we'll see why we need to do that as well. And I also want to do a little bit of troubleshooting along the way to give you some tips and techniques. So when Kerberos doesn't work, you don't panic and turn it off and go back to NTLM. What you do, or worst case, you go to basic auth or something like that. I want to show you how to actually troubleshoot it as we go. Some good tips on that. Normal thing, you know, don't put this straight into production. Just test it out before you go. And I'm sure you've seen this slide by now, so a number of times. So I'm going to go straight in. The nuts and bolts. The first thing is we need to authenticate to a server. So we come in and we authenticate, and there's lots of different ways we can authenticate, you know, such as NTLM, Kerberos, and so on. First process. The next job we need to do is we need to authorize. So who is being authorized to do what? So two key components. Two solutions. And if anyone come on the authorization manager session yesterday? Okay, so a few of you, so you've seen this slide already. Two basic approaches. We can go for a trusted subsystem, or we can actually go for delegation and impersonation. With a trusted subsystem, what's happening is the process that's running is going out using its own identity to gain access to the back-end systems. All right? And then it's deciding whether someone is authorized to do something. So that's your web app, is making those authorization decisions. Today, what we're going to look at is we're going to go out to the back-end systems, and maybe local resources as well, using impersonation. So our user's coming in, it's coming into our process, which is running with some ID, and then we're going to impersonate the user that's come in and go off to local resources, and then through delegation, go out to back-end resources. So in terms of security considerations, in terms of trusted subsystems, the application is probably running at some fixed identity, although it doesn't have to. You can mix these things up together. And the application is controlling the authentication. If you were using forms-based authentication, it would be the app or underlying .NET that's actually managing the authentication. The application must control the authorization and the auditing, unless you use a third-party component to do that. Because basically, you're going to a back-end system using the application pool's identity. So no native auditing there at all, and no native authorization. You've got performance optimization because you've got the capability of doing connection pooling. Right? Whereas if we go to the back-end system using delegation, then we've got individual connections going into the back-end system. And the server number one, which is our front-end server, does not need to be part of the Active Directory. It doesn't have to be. If we go for the delegation impersonation model, then impersonation requires a high level of trust. Actually, I would say both of them require a very high level of trust. You have to trust your application developers. And that's why it's very, very important as infrastructure people and security people that we actually understand what's going on. So we can talk to the dev and say, yes, you can do this. Or if we start configuring the Active Directory, we're aware of exactly what we're doing. So if your dev guy says, I need to delegate, you need to understand exactly what's going to happen when that delegation occurs. If we're impersonating, then we've got native authorization. So we hit the file system, we can use the NTFS file system permissioning, and we've got native auditing in there as well. Scalability, all right? We've got scalability in terms of the delegation and person model. You have problems with that because you're building multiple connections to your back end rather than your connection pooling. And you require Active Directory membership and configuration. So we need to be a member of the Active Directory to actually handle delegation. So our front-end server will need to have that. So servers must be members of the Active Directory. The authorization protocol from server 1 to server 2, so server 1 is the server our client is hitting, is always going to be Kerberos. The application pool identity on server 1 must be trusted for delegation. So if we're going to go from server 1 to server 2, it's got to be Kerberos, the authentication protocol there, but we've got to trust the account that is actually making the connection for delegation. And Maria's account, and Maria is coming in from the client out here somewhere and hitting server 1, Maria's account must not be marked as sensitive. If it's marked as sensitive, she's not going to be able to forward a ticket to be actually passed on. Right, this is a summary. We will get to the details of this in terms of account sensitivity. Now, pre-Windows 2003, what we had is the authentication protocol from Maria to the front-end system had to be Kerberos. So for a web application, that was absolutely useless. Right? So it worked on the intranet, fine, but if we're coming in from the web with some other protocols to do the initial authentication, we could not do the delegation. With Windows 2003, right, we can actually change that. What we can do is we can come in with all sorts of different protocols on the front end and do a protocol transition. And protocol transitioning is absolutely great. It's potentially very dangerous, though. So we actually have to understand it and see where the risks are. So in terms of our protocol transition, front end, WDigest if you want it to be, NTLM, forms, client certs, RSA, secure ID, basically anything, and we can do this transition. To allow access to the back-end servers using Maria's identity, server 1 transitions the protocol, say from NTLM, to Kerberos, right? And at that point, it has to be very trusted at what it's doing, and we'll see how that works later on. And Maria must actually have a valid Windows identity. So if you come in through WDigest or you come in through forms, Maria, if we're going to do the transition, has got to have a Windows identity, because basically what we're going to do is we're going to transition to a Windows security principle. What constrained delegation does for us, it basically constrains where we delegate to. We're working in 2000 environment, enable delegation, and this guy can go off to any server it likes. right? And that's a real danger. With 2003, we can say which servers it can go off to, but we can be even more granular than that. We can say which services on which servers it can go off to. And those services are actually identified by an SPN, as in a service principal name. So we've got to set all that up for that to work. Constrained delegation protocol transitioning actually requires Windows Server 2003 domain functionality. Anyone been following the 2008 track and been hearing about read-only domain controllers? All right, well, that's the reason we need 2003 domain functionality to actually use a read-only domain controller, because it's using the protocol transitioning. Keys to success. You've got to have a test environment. Otherwise, you'll drive yourself absolutely nuts. So we need a test environment. We need a knowledge of application identity. So we need to understand how an application actually runs and what identity it's running in. We will need knowledge of Kerberos. Not detailed knowledge down to sort of minute bit detail, all right, but detail of the protocol messages that go across, so we can actually open them up and see what's being asked for. And if you do that and you look with a network trace, it actually solves a lot of troubleshooting problems. We need to define service principal names. We need to know where to define those service principal names as well. We also, there are lots of different configuration options. We can delegate, we can have constrained delegation, we can have constrained delegation Kerberos only, all sorts of different configuration. We need to know where to configure it. We can also change the sensitivity of a user account as well. Monitoring the network is important, and a very useful technique is to use auditing. After all, you're doing a native way of going in, so especially if we're going from server 1 to server 2, auditing is a really good troubleshooting tool. My demo environment. So I have a demo environment where I have two clients. One is not a domain member. It's out there on the internet, we could pretend. One of them is actually a member of the domain. So client 1 is a member of the domain. I have an application server, app1. I have a backend server. I have a domain controller. And I have a little .NET app that I've written just purely for this demonstration. Actually, I've got two of them, all right? And it's a very simple application in the terms that what it's doing, I started off writing a SQL app, and then I decided that actually it was going to get too complicated to really demonstrate well. So all it does is got a couple of buttons, all right? Well, it's got 3 buttons on it, and click 1, it accesses a local resource. Click 2, it accesses a resource on app 1, and click 3, and it goes to a resource on the domain controller. And it's a file system resource. Why? Because it's nice and easy to audit. Right, but it shows you everything you need to know. So no impersonation involved, because we're not impersonating someone. Then I put a little table there, which is actually quite useful to remember. I'm not going to go into all the details. I just point out a few things in it. And basically, you can have it, you've got it there in the slides. So the pool identity, this is the identity of the application, that's running at network services. Local access is network service. And remote access is going to use the computer account, right? With no impersonation, if we're using the domain account, so we're running under Web 1, which is a domain account, local access will be Web 1, and remote access will be Web 1. Remember, no impersonation at this point in time, okay? And then I've got local system and also, local system really. Anyone run with local system still? Anyone want to confess? Oh, there's a few hands. Thank you for confessing. Okay, so when you actually create and run under a different account identity, what we must do is make sure that that account is a member of the IIS WPG group, which is the worker process group. When you specify the account, also make sure that if you're specifying the account to run under a different identity, make sure you specify the domain and also the name of the account. So Web 1 is an account, right? It's just a straightforward user account. I created the directory, and I need to specify that when I run my pool under that identity. As soon as we go and we use impersonation, but with no delegation, things change rather a lot. So if I'm actually coming in, I'm impersonating Maria. So everything locally is actually accessed as Maria, right? But everything remotely is accessed using anonymous, right? And you can use anonymous if you want. You can enable anonymous access, and it does work. Anyone use anonymous? Anyone really want to confess? Not a single hand. What a relief. Okay, so don't use anonymous for your back-end systems, but it's quite possible to do. If you want to do impersonation, then you must have the SE impersonate privilege, right? By being a member of the worker processor group, you've automatically got that. So by default, you can always impersonate. Now, troubleshooting, auditing, absolutely essential. We need auditing on for seeing what's going on in our systems. So make sure you've got auditing on. And obviously, there's two places we put auditing on. We put auditing on through group policy. And there I've got auditing for success and also success and failure on object access. And we then need to enable a SACL. So let's have a little look at my system. So what I have is actually my two clients. So that's client number 1. I have client number 2, right? Client number 2 is not part of my domain. I have a domain controller with a rather yucky green color. I have app 1, and I have app 2. So I've got those systems. And then if I go to app 1, this is my IIS server. So let's actually just have a look at what's going on there. And I've actually got two applications I'm going to be using today, or two websites. Got File 4000, and I've got another one, Transition, which we'll come back on. So let's just drill into here a second and right-click on there, Properties. And if we have a look, we'll actually see that this guy, in terms of the website, he's got his port number at 4000. If we click on Advanced, we've got no host header in there. OK, in terms of directory security, edit that. We're running integrated Windows authentication. Right, and if we click on website, as I said, the important thing I just want to absolutely highlight is there's actually no host headers there. Home directory, the default application pool is currently what we're running at. So what's the identity of our default application pool? That's right. Let's go up to application pools. There's our default application pool. Right-click, properties. And the identity is network service. Okay, so that's actually how the thing's set up now. So I'm going to go from my client machine, which is actually part of my domain, and I've just got a shortcut here, and off it goes. So this is our file access demo. It's hitting port 4000. Local resource, I've accessed it. By the way, I'm logged in here as Maria. So we've got Maria logged in here. And I do a remote resource on app 2, that worked, and I did a remote resource on domain controller, and that worked. Important thing is, what on earth is going on? All right, we need to know that. So let's go back to the DC. So just going over to the DC here, and bringing up my group policy management, I have an audit policy, which applies to both of my servers. Let's just have a look at that. And under the Windows settings, security, drill down to the local policies, audit policy. And what I can see is here I've got audit logon events, and I'd advise you auditing for success and failure, because when you're getting this all working, you're bound to fail a few times, unfortunately, and auditing object access. So that has already been in place. The other thing is, of course, we want to do is we actually want to audit, and I'm going to look at my app number 1. The file I'm actually hitting on app 1 is down under a folder called data. And look in there, that's the file I'm actually accessing. So I'm just going to right-click on data and go down to properties, security. And what I want to do in here is just go to the advanced settings, auditing. Currently, there's no auditing, so I'm just going to add in everyone here. So put in everyone, and I'm going to audit for success and failure for everyone. Okay, so now my auditing is in place. Right, I've already done it on app 2, and I've already done it on my domain controller as well. Okay, so let's go back to the application, and then just let's hit the local resource and hit the remote resource. Okay, so back we go. And if we have a look now, oops, one more, and have a look on here and look at my event viewer, security, just refresh that up. And this is app number 1. This is where my IIS is running. So if we have a look at this logon event here, we can see that we've logged in as Maria. We can see we've logged in as Kerberos as well. So if you're wondering if you made it with Kerberos or not, it's a good place to look. Okay, let's go up to the next. So here, data test.txt accessed as network service, which is what we expected, right? Because we're running the application pool as network service. So, and we got no impersonation going on at the moment. So when we hit the second server, again, security logs, and looking in here, let's pull that out. Again, now here we've logged on as app $1 because we're running as network service, so it's the computer account that's gaining access to the back-end system. Right, let's just have a look at the next entry, and we'll see that the share and text.txt was accessed as app $1. Okay, our next job is actually to turn on impersonation. And we could do it and do it individually for an individual API call on here. But what I'm going to do is actually turn on impersonation, and I'm going to do it for all of my all of my calls. So I'm going to go to my inet pubs directory, down into File, bring up my web config, and just modify it. Very, very simple web config. But at the moment, I've said no impersonation. So I'm just going to change that to impersonation equals true when that comes up. And then we'll actually do in here, so impersonation is currently false. I'm going to say true, which basically means it's going to impersonate all calls, right? As I say, you can impersonate individual calls. There's a much better way of doing it. Rather than changing the web config, say impersonate everything, just impersonate individual calls, which I've got actually set up later. So I need to save that. Okay, so back over to my client, and so we'll just close that off and start him up again. So local access, so again, and we are being prompted, okay? So if we're being prompted, it means basically the credentials we passed are not acceptable, and that's why it's tried already. And it's being prompted. If we click cancel, I haven't actually put any debug code in here, so it's actually bringing up my .NET error message, app2 share test.txt is denied. Right. So again, scratching head time, but remember we got on auditing. So if we go across to application number 2 and actually have a look in our event log. So who's going to have accessed the system in, this application server number 1, this IIS server, who's going to have accessed this particular file? Maria. Okay, so let's do a refresh on there. And that is probably it there. There's Maria, okay, and logging on, Kerberos, and there she is accessing the file. Okay, if we go to our back-end system, and so on app 2, who's going to have accessed it here? Anonymous, yes, you were looking at the slides, or you already knew. Anonymous, all right, because we got no delegation, so it's going to use anonymous. So we should find we've actually got an anonymous logon. And so we've got an anonymous logon. Actually, if you scroll through this lot here, let's have a look at the other logon. We can actually see, where are we? Anonymous logon, yeah. So the user log off, we should find actually, will find an anonymous logon at some point, and you will see it's actually come from @1. So you can actually go through and see where the request came from. But the important thing is the attempt was made with anonymous. So that's not actually going to work for us. So what we need to do is go a little bit deeper. Okay, so how do we enable delegation? It requires Kerberos, okay? And if we look at the Kerberos, there's a number of players involved in Kerberos. Who would like to be a file server? I need a number of volunteers. Anyone want to be a file server? So can you come down, sir, and be a file server? Who would like to be a domain controller? Thank you. Please come down and be a domain controller. So, hello, Mr. Domain Controller.
Hello.
Hello. Hello, Mr. File Server. Okay, so would you like to come over here, Mr. File Server? You stay there, Mr. Domain Controller. Right. If we use NTLM authentication, all right, what it's going to happen is I'm going to come knocking on his door, bang, 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 and I'm going to say, let me in. And what he's going to do is pass me back a nuance. I'm going to encrypt that with my password, or hash my password, and pass it back to you. Can you authenticate me?
It's the Quintus.
Yes.
If I'm connected to the domain controller, yes.
Yes, so what do you do with what do you do with the nuance you sent me and what I've sent you back? So I've encrypted the nuance. What are you going to do? You're going to ask that guy, am I all right? So you pass it back, and we're in. Okay, so that's NTLM in a nutshell. Challenge response. You have got to go up to the domain controller. Okay. I need another component of the domain controller. Another volunteer. Come on. There is a little present afterwards. It's a very nice little torch. Come on, we need one more component of our domain controller, and I need one more. No, I need two people. So, right. So can we have now? Can you just stand here as another component of the domain controller, and if you go over there as another file server? Fantastic. Right. You're the orange file server. You're the green file server. You're the authentication service, and you are going to be the ticket granting service. Right, so you just hold on to that. Okay, log in. What I do is I go to the authentication service, and through a process which I'll show you in a bit more detail in a minute, checks me out, and if I'm a good guy, what do you give me? You give me a ticket granting ticket. Now, I forgot to give you your props. Yeah, you hold on to both of those. So now I want to go and hit the green server, right? Because we're now in the Kerberos realm. So I take my ticket granting ticket to the ticket granting service, and I say, can I have a session ticket, please, for green? Thank you. And now I take this back to the green guy, and through encryption, he knows it's a valid ticket and allows me straight in. So did you have to go and ask any domain controllers? No, not at all. So that is basically Kerberos, right? What we need to do is get into a little bit more detail. So thank you very much, guys. Here you are. You can, by all means, keep the, if you want to keep the microphones. Thank you. Thank you very much. Thanks. Give them a big round of applause. Come on. Well, that was simple, wasn't it? So just remember, it's just about colors. Okay, with the players. Who are the players involved? The user. The computer we're going to hit. Actually, it's a bit more detailed than the computer we're going to hit. It's actually a service on that computer. But we'll say it's the computer we're going to hit. We need a database of security principles. And basically, those two components, the authentication service, the ticket granting service, are combined in one in the KDC. And the KDC, the Key Distribution Center, runs on all domain controllers. Right, we've got our users over there. We've got our server accounts over there as well. And what we need to do is, when I got all those little messages passing around, we need to know they're genuine. So we need a bit of encryption in place. And we need some keys. So the user's got a key. When the user logs on for the very first time, we can generate a key from the user hash. We might not want to keep using it, because that would be a security risk. All right? Who knows about that password? It's in the database, isn't it? So we have a matching key up in the database over here. When we join a computer to the realm, right, or to the domain, we want to talk Microsoft speaky, but it's really a Kerberos security realm, right? So we got a key on there, and we got a key sitting in there. And our KDC has keys for everybody, right? So now that guy over there can encrypt something and we can have an encrypted exchange between the user and the KDC, and we can encrypt something that can be passed back that only the server and the KDC know about because of the keys. Okay, so Come on, click mouse. Big picture. John requests authentication. TGT comes back. We ask for a service ticket, and we pass back the TGT. The advantage of the TGT is the transaction is stateless, so I can go back to any KDC. So I may have got my TGT from one KDC, but I can go back to a different KDC for the service request. ST comes back, all right? That is only valid between John and server 1. So you've automatically got mutual authentication, because basically the only guys that can talk together are those two characters. So I know that if I've got a connection, I'm actually talking to the right server. So the TGT, so as I say, it avoids holding logon factors, because basically what we've got back is this sort of passport, if you like, that we use for all subsequent transactions. And then we've got the service ticket, which is only valid, as I say, between the two. So I've already covered this slide by just talking through the last one. And encryption is used just to ensure that these messages are genuine. So initial logon. What I do is the user passes through the client principal name, the timestamp, right, and the KRBGT principal name, which is the name of this guy, and the requested lifetime for the ticket. And the client, this is the sort of general protocol, and you can request that. And what this guy, what this guy will do is he will actually check that what you pass, he won't do any checking at this stage that that's genuine. But what he'll do is he'll accept you are who you say you are, and he'll send back an authentication, right, which is encrypted, and only the guy over there will actually be able to decrypt it, right? That in itself is a potential risk, because what you could do is you could actually pile requests at the ticket granting, the authentication server, and it would be responding all the time. So the normal way of working is to use pre-authentication. And with pre-authentication, a component is actually encrypted with the user's key. Right? You don't have to use pre-authentication. In the Kerberos protocol, it's quite okay not to. But the problem is, somebody could sit there with a client machine just generating requests, and the old KDC would be replying all the time. So what happens now is we encrypt the client timestamp with the key generated from the password hash. The guy at the other end gets hold of this, and if he's happy, because he can decode that, if he's happy with the timestamp and it's within the skew period, he'll say, yep, that probably is the genuine person. So he'll reply. 2003, by default, uses pre-authentication. And you may have seen, if you've seen on the user account, if you look through the general properties of a user account, you can actually turn off the need for pre-authentication. I'm going to be going there in a minute, and I'll show you. Right, next job. So we've actually got a reply. So the next thing we do, this is we've got the initial transaction. We're now generating our reply. So we've got in here a TGT, and we assemble the TGT. And inside the TGT, one of the things is the pack. The pack actually holds all of your group membership, and that's held in the TGT. So what we do here, we've got this key that was generated from the hash of the password. Over here, we also generate a user to TGS, ticket granting service key. We put that key in both the TGT and the user's TGT key. And then we encrypt that lot with the user's key derived from the actual password hash. Okay, so the user is going to be able to decrypt that. And then we encrypt this lot, right, with a key that only the TGS service knows. Right? Pass that back to the user. What can the user do with it? The user, when he's got it, can extract the user to TGS key, because he can decrypt the top part, the bit in pink, so he stores it. Right? Now, he doesn't need to hold on logon factors. So we've now generated a key that is going to last until we have to regenerate the ticket. Right? So it's going to last for the ticket lifetime. Having done that, what he'll do is he'll take the TGT, you can't do anything with it, it's encrypted. It's encrypted with a key that only the ticket granting service knows. He just holds it. He's got it now. So it's like being given a passport. I mean, if you think of this as a passport, it's got all your details inside it, but you can't actually look in it. But when you go through passport control, they can open it up because they know the key. They open it up and check it all out. So we're just holding this. We can't go inside it. So now what we do is we want to actually ask this guy over here for a session ticket. So what we do is we need to actually be able to talk to him. And when we send back the TGS request, what's going to happen is the server over on the other side, which is our ticket granting server, is going to be able to crack this lot open and extract the other half of the user's key. So now I can talk to the user. But because we encrypted the TGS with the ticket granting services key, right, and put the user to TGS key inside it, it means we can go back to any key, any KDC. All it means is the KDCs, all KDCs need a common key. And then I can send that passport back to any key distribution center, and it will be able to open up the TGS, get the user to TGS session key out, and talk to the user. Right? Everything's not encrypted. It's only enough to get the protocol to work and remain secure. OK, we asked for a service. And we asked for the service ticket. What we're doing is, in there, in clear text, right, it's the service principal name. And that is the bit you want to look at when you're trying to troubleshoot. So you grab that off the network. Is the client asking for the correct ticket? We've got the TGS, and we've got an authenticator, which is basically a client timestamp and a bit more, to show that it genuinely arrived from that client, and it prevents against replay attack, and so on. So now, when the service ticket reply comes back, and we generate a user to TGS session key, all right, and we place that in the user service key there, and we've got it placed in the service principal top part and also in the session or the service ticket lower part. The top part is encrypted so only the user can get at it, and the bottom part is encrypted so only the server can get at it. The client gets that lot back. The client extracts that key. He's now got a key he can talk to the server with, right? And he then holds that. He can't open it, it's sealed, right? He can't get in there. The only person that can open up that component of it is the server. So now we're in a position to actually finish off and actually talk to the server. So we can talk to the server. Again, we need this encryption. We need to exchange, have both sides have matching keys. So basically, we send the service ticket across. The server can crack that open. He's now got a key which he can talk to the client. Right? And that's basically the mechanism that Kerberos uses. Now, you will see the AS requests. You will see the TGS requests. You won't necessarily see the requests going between the user and the server that the user is trying to hit. The reason being, it's buried in other protocols. So if we look at SMB and we crack it open with the correct protocol analyzer, we will find it inside SMB. But to be honest with you, it's pretty useless to it because it's all encrypted. The most useful component to us is the session ticket request to talk to the service. And what we can do is check that the client is asking for the correct service principal name. Okay, if we look at delegation, then a client can forward the credentials to a service. So what I can do is actually forward my credentials to the service. And then the service can go off and ask for a session ticket on my behalf. And that's what delegation is about. So to be able to do that, it's going to forward a copy of the TGS. So the service can say, hey, look, I'm John, or I'm Maria. Can you give me a session ticket to the back-end system? Right? So that's what we're trying to do. For the credentials to actually be forwarded, there are various flags on the ticket, and we can actually look inside those flags, and that's, again, another really good way of troubleshooting. And the client's TGS must be marked as forwardable. So here I've got a TGS. I've got to be able to forward it, so it must be marked as forwardable, all right? And the service ticket must be marked as OK as delegate, all right? So we need TGS to be forwarded and the service ticket to be OK as delegate. And the flags are set by the KDC when the tickets are actually issued. And we can look at those flags. So in terms of the account configuration, what we need to do is actually arrange for Maria's account not to be marked as sensitive. If it's marked as sensitive, she will not have a forwardable KDC. The KDC will not issue a forwardable TGT, right? And then the server must be marked as trust this computer for delegation to any service. And notice it's Kerberos only. That is the same as the Windows 2000 delegation, right? In 2003, we have the extra functionality shown below, but we'll get to that very shortly. Okay, so if we want to actually view the flags, the best way of viewing the flags is actually to view the flags and to use curb tray to do it. And when connecting to a website, you will see all the tickets unless IE is configured to you won't see all the tickets unless you configure IE to automatically authenticate. So you actually want to make sure that you're not being prompted for a dialogue. And that way, the client will actually hold all the tickets. Otherwise, IE itself can cache its own tickets. So to see all the tickets, make sure that you've got automatic authentication against the back-end system. And if you want to purge your tickets, use KList. Okay, so I'm going to go to my client number 1, first of all. So we'll switch over and off to client number 1. And on client number 1, I'm actually going to run up here. Let's just close that off. I'm going to run up the curb tray. So, and curb tray goes and sits down at the bottom end here. So if we look at our tickets in here, we've actually got 2 PGT tickets, all right? One, if we look at it, we look at the flags. One is, well, let's do the other one first. One is initial. This is the initial one it's got. If it's capable of getting a forward one, it gets a second one, okay? Notice it's forwardable. So we can actually forward it across to the other end. HTTP app1.sellers.example.net. That is the server I'm hitting. That's my server number 1. Let's look at that one. OK as delegate. It is not marked as OK as delegate. Therefore, that ticket will not be forwarded across to the other side. Right? So if we enable delegation, that will change. So I'm going to go into Active Directory using computers, so across to my domain controller. So let's fire up Active Directory using computers. And the first thing is I'm going to mark Maria's account as sensitive. So we go down into here. I've actually got, we got sellers, we got users in here. There's Maria. I'm going to double click and look at the properties of Maria and look at the account properties. And let's just go down through this. Do not require Kerberos pre-authentication, so you can turn it off. Okay? Account is sensitive and cannot be delegated. Personally, I'd like Microsoft to tick that box and you unsensitize the account, all right? So all accounts, as far as I'm concerned, should be sensitive. And what we do is actually we script a change in the Active Directory, especially if there's any sign of delegation being used anywhere, and every account becomes sensitive, and you basically clear that off for the accounts that you want to not be sensitive. Okay, so what application pool identity are we running with? It's network service, isn't it? But in terms of the application pool identity for going to the back-end system, it's app1. So we need to go down to app1. So under our servers, we go down to our IS server, there's app1, and we go to properties, and we've got under here, delegation. And we trust this computer for delegation to any service. Okay, So at this point, what we need to do is we can actually go back, and we can go back to over to Maria. Now, if we don't do anything, those tickets are going to remain there. So what I'm going to do is actually, I'm going to do in here, I'm going to actually run up, whoops, let's not do that. Let's run up a command prompt. And I'm going to use klist. And what klist does, we can use klist purge. And it's going to purge out all the tickets. So yes, 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 yes. Right, they've all gone. So we've just done a klist purge. So if we look down here in curb tray, all the tickets are gone. Okay, so now let's hit that application again. Okay, let's have a look. What have we got? We've got only one TGT now. All right, let's have a look. First of all, let's have a look at the app 1.1 and look at the flags. It's okay as delegate. All right, so we've said that guy is good for delegation. But we've only got one TGT issued, and notice it is not forwardable. And the reason of that is because Maria's account is now sensitive. Okay, so we'll actually go back and actually change that, and we'll go back and mark Maria's account as non-sensitive. So we go back into Active Directory using computers to do that. And where's Maria's account? Sitting down under users. So Maria's account in there, and we go to account, go down here. So now we'll mark it as non-sensitive, and we'll have to go back again. Oops, did I click OK on that? Yes, I did. Yep, I think I did anyway. Let me just double check. Yep, that's fine. Okay, so I'm going back to my client. Once again, I'm going to have to purge my tickets. Let's just close that. And remember that all tickets have a lifetime, and if you don't purge them out, things are not going to change, because I'm not going to bother to go off and get another ticket when I've got one. So that's another thing to remember when you're troubleshooting this, is remember to purge out your tickets. So yes, yes, that's all done. Right, just check that, everything's purged. Okay, so now let's start up the file application again, and let's just check our tickets. So now we got two TGTs, right? One is part of the initial request, one is part of the one that's going to actually be forwarded on. And so we'll see, I think it's probably fairly obvious, but that is now forwardable. And also, this guy is okay as delegate, so in theory, it should all work. So local resource on IIS, there we go. So now, who are we hitting app 2 as? Who are we getting over as app 2 as? As Maria. Let's have a look. And again, this is why auditing is actually so useful. There you go. Maria is accessing data test.txt. So that's got the delegation component working there. And so impersonation does actually work. Let's go to client number 2. So client number 2 is not part of the domain. So I'm going to go back to my client number 2. I'm going to go to File App. And I'm being prompted for logon, so we go sellers, Maria. And okay, so what happens over here? So we've actually come in here, local resource, fine, no problem. Fails. So why is that? What are the rules? It's not a domain member. Okay, so what can't it do to the front end? Kerberos. And if we're using just delegation, right, it is the Windows 2000 delegation which requires Kerberos at the front end, right? And that's why it's failing at the moment. And, you know, if you have any doubts as to what's going on, what we can do is we can actually do the auditing on app 2 and just close that off, just refresh that, and let's have a look. The logon, Maria, is coming in using NTLM, all right? And if you just use the straightforward delegation, and that was the straightforward delegation as it was in 2000, and it is in 2003, unless you're in 2003 domain mode, that's basically, you've got to be Kerberos in at the front end, because the only way it can work is by passing on the tickets, and that's why it's fake. This guy doesn't have any tickets to pass on. All right. So let's move on a little bit. So back to the slides. You see the pictures beginning to build up. Service principal names. So what basically a service principal name does is it identifies the service that is running in terms for Kerberos purposes. So when I want to talk to a computer, I'm not actually connecting to the computer. What I'm doing is connecting to a service on the computer. So if I was connecting to the file print service, I would actually be looking for a service principal name of CIFS, as in the Common Internet File Service. Right? If I was connecting to the Active Directory, what do you think the starter of that would be? LDAP, yeah. So what we've got to do is have the correct service principal name actually incorporated. And if you actually view the service principal names, and you can actually do that, we can look at the service principal names, and you won't see, if I looked at a domain controller, I wouldn't see all of them there. A lot of them are built in. There's a whole series of them built in, which we'll come back on and see in a moment. But if I want to do something special in terms of delegation or in terms of gaining access to a particular server on a website, then I will need to register the correct service principal name. So how do we set the service principal name? What we do is we use set SPN. All right? -A, as in add, the service principal name itself, and then we need the service principal name can have an instance name, and it can have a port number on it as well. And if we were connecting to a back-end SQL system, we would add the port number in. Okay? And we then want the service name, and basically that is the account name of the service itself, which needs to be added on as well, because we have to place it, add this to an actual security principal. It's the security principal that is acting as the identity of the service, the gotcha. And this is the one that floors a lot of people. And this is the one that actually, the reason that in SharePoint you've got NTLM authentication. What IE does, if you connect to HTTP server :1000, what it does is it asks for an SPN and truncates the port number. All right? So we can't differentiate for Kerberos purposes between different websites on the same box by port number. So what do we have to use? Host headers. You've got to use host headers. Okay. So let's get into that now. So what I'm going to do, my first job in here, is to actually go back to, okay, so we're going on app 1. I'm going to come into app 1, and I'm going to go down to the right-click on my website, and I'm going to go into the home directory, and I'm going to switch over and use web as my application pool. Okay, so I'm going to go over that first of all. Okay, that. And I'm just to be absolutely safe, I'm going to do an IIS reset on that. I could probably respin the actual account itself, but sometimes you have problems and just prefer to do an IIS reset. So I could just recycle the pool. While that's happening, let's actually just have a look at the pool identity. So we've now used running with web, and because I've done an IIS reset, it dropped the connection. So if I look at that, properties, identity, and that's running with an account, and you just created just like an ordinary user account called Web1, okay? And obviously you need the correct password in there. Okay, so now let's go back to client number 1. So back over to client number 1, and let's just clear up a bit, because that's actually client number 2. So client number 1, I'm going to have to close that off because we did an IIS reset. And I'm going to now go across to my box, and the connection fails. Not authorized to view this page. It's turned on, you know, Kerberos, why doesn't it work? So what we have to look at is actually what client number 1 is asking for. And one of the best ways of doing that is actually to do it with a network monitor. But the interesting thing is, let's go over to client number 2. And of course, if we go to client number 2, and we're going across here, so sellers with Maria. That still connects beautifully, okay? But suddenly, you know, we've spun it up with a different application pool account. We can't connect to it anymore. And this is where you sort of tear your hair out and think, what on earth is going on here? All right, let's go and have a look at the audit log before I use the network monitor. And I'm going across to number 2, event viewer, refresh that. Woo-oo, fails. Unknown username or bad password. And you so think about that for a while, and you scratch your head, and what's actually happened is if it couldn't negotiate Kerberos, right, it would drop down and use NTLM. Right? But what it's gone off for is it's gone off for a Kerberos service ticket to the address :4000. The IE's truncated the 4000. So what it's got is a service ticket to port 80 on that web server. Right? Port 80 is running with one identity, and the one sitting at 4000 is running with a different identity, and it's the wrong identity for the 4000 port. So that is what we've got as a problem. So let's put some host headers in. So we're going to go back in here, and we're going to go to File in here, and actually in here put a host header in. So we're going to the Advanced Settings here, select it, edit it, and I'm going to put it back to 80, because we can do that with a host header in. And I want a host header in there of, what do I decide to use? And just check in there, yeah, www.sellers.example.net. Okay, www.sellers.example.net. That's fine. So we've now got a host header in. Okay, I'm just going to respin that. So just do an IS reset on there. And while that's happening, let's just pop over to my DC. Oops, sorry, gone past it. Pop over to my DC, bring up DNS, and we just need to pop an A record in here. So we've got an A record, and it's www, and it's going to be to this guy here, which is the @1, which is so in here it's 10.30.5.1. Add that in. Okay, that's been added successfully. That's all done. We've finished with DNS, and let's go back to client again. So client number 1. So do you think it'll gain access this time? No, so I'm going to have to go for this one. Do you think it'll gain access? Right, so sellers. And why am I being prompted, by the way, for credentials? Because I'm no longer in the intranet zone, because I'm using a host header. So IE differentiates between the intranet zone and the internet zone. Basically, if you haven't got a dot in the path, it's intranet. If you've got a dot, it's considered to be internet. So let's just go in here. Password. I'm in. Why has it worked? The SPN is missing. So what's it done? It's dropped down to using NTLM. Right. So I've now authenticated using NTLM, because basically what it's gone off and said, please, Mr. KDC, can I have a service ticket to www.sellers.example.net? KDC says, no, I haven't got one. So he says, okay, well, if you can't give me one, I'll use NTLM. Whereas previously what was happening, which is the real gotcha, it was IE stripping off, all right, the port number. So it basically got an SPN for the wrong service and presented this SPN as though it was a good Kerberos guy. And that's why it basically said, go away, your credentials aren't right. So now we're in and we're fine. So the next job is to actually put in an SPN. So I'm going to go to, in fact, actually, just before we do that, let's just go across to my application server. And again, let's do the refresh the security log on here. And just do a refresh on there. And the log on, we've got to get the right one. There's a lot going on here, so hang on. I'll tell you what I'll do. Let me just pop back to the client. This is probably the easiest way of doing it. Local resource. It's just so I can actually I've got a marker in the, and just refresh that. So my marker in there is, oh, you know, it would help actually if I was on, sorry, help if I was on the right machine. Now I've got a marker in there. So we are actually looking at object access here. Maria NTLM. Okay, so it fell back to NTLM. Okay, so next job is actually put a service principal name in. So over here, I'll do this on the DC. In fact, I mean, this has got so much junk open. Okay, so on the domain controller itself, I can actually now, on domain controller, I can actually bring up a command prompt. And what I want to do here is I'm going to do set SPN. And so set SPN, we actually then need HTTP forward and the actual website address, so www.sellers.example.net. And where do I put it? Web 1, because that's the application pool that it's running with. So HTTP www.sellers.example.net, and I need a -a in there, as is going to be an add. So -a to add that in, and I need to put it on Web 1. So sellers/Web 1, which is the security context that pool is running in. Okay, so run that up. And always, I suggest, is actually having put it in, you do actually list the SPNs on that account as well, just to make sure that it has been correctly configured. Because, you know, just take it, you get as much information out of the system as you possibly can. So I'm just going to bring that back. So sellers, there we go. Let's bring that back. Just delete that lot out. Okay. List. Okay, so I'm basically listing the SPN on the Sellers Web 1 account now. And that will just, setting SPN always takes a while because it actually goes through and enumerates everything. So HTTP www.sellers.example.net. Okay. So let's go back to my client and let's actually do on here, I'm going to, on here, I'm actually going to do now a purge that lot out. So I'm going to use klist, purge all my tickets. Okay, so that's done. Bring up my connection in here. I'm still being prompted. Okay, so I've gone in, I'm being prompted, that works. Back-end system, still not working. Let's have a look. No Kerberos tickets. All right, what we need to do is we actually need to add this. It's got to be a trusted zone before it'll actually work. It's got to be a trusted site. So let's go to Tools, Internet Options in here, and Security, Trusted Sites, and we should add this guy in. Unless he's added in as a trusted site, you are not going to get Kerberos working. So he's now added in. Okay. So let's bring him up again. There you are. No prompt. Local resource. And we're still not going out on the back-end system. So let's actually have a look. So we've got, let's have a look. What have we got? www.sellers on here. So that's fine. and we've got, let's look at the flags. So that's okay. That's in here is not marked as okay to delegate. All right. But is that forwardable? Yes, it is. So what have I got to do now to get this to work? Yeah, I've got to go and actually go to that account and delegate that particular account. So on here, if I bring Active Directory using computers, I don't need, and this is quite a common misconception, I go to my IS server, that no longer is required to delegate. I don't need it. All right, so delegation, turn it off. All right, you delegate on the account. That's all you need to do. So now we go to the account, and this is quite interesting. Let's go to, sorry, service accounts, web 1. Notice anything unusual? The delegation tab's appeared. Why? Because it's got a service principal name. And that's when the delegation tab appears. Okay, that. All right. So now, if we go back on here, we can actually go and go back to the client. Close that off. Let's open it up again. Oops, that didn't work. And what we'll need to do is actually do an IS reset on there. So it picks it up. Oh no, actually, sorry. Yeah, the reason I need to do an IS reset on here is because this guy has already got a bunch of tickets, and we need to actually, we can purge its tickets by doing an IS reset. So although sometimes you could respin the account up, to actually purge out all the tickets, it's much safer to do an IS reset. I'm just going to go back over to the client as well. We're going to have to purge those tickets. So klist and there again, purge those out. Okay, I'm going to close that window, open them up again. And we're now local resource, remote resource, everything's working beautifully. Okay, so we've got Kerberos in at the front end on this. We've actually got a different application pool identity, and everything's working beautifully. Can you show the tickets in Web 1? No, what you can do, you can't see them automatically. What you can do is actually run a command prompt up, right, with the same, so you can actually run it up with the application pool identity, and then you can actually use klist. So you can see them if you do that. Okay, so in terms of Windows 2003 extensions, what's allowed, provided you're running in Windows 2003 mode, you can actually go and we can set up to do the front-end service can now directly request session tickets without the need for a forwarded ticket. So my front-end service can actually go off and say, give me a ticket for that particular person, all right? And provided everything's set up beautifully, we can then delegate to the back end. The KDC only grants ticket for service to which the front-end service is allowed to delegate. And this is where the constrained delegation comes in. So it will be issued for this back-end ticket. So in terms of constrained delegation, we can say use Kerberos only, all right? In which case, what's got to happen is it's got to be Kerberos in at the front end, all right? And that's use Kerberos only. And then where do we go off to? Where are we allowed to delegate to? To services. And those services can be identified by the service types such as CIFS, HTTP, etc. Or they can actually be identified by putting in a port number as well. So we have the service name and we can put port numbers in there. But remember, IE strips off port numbers. So in terms of the protocol transitioning extensions, with the protocol extensions, it allows the service to obtain a Kerberos session ticket to the service principal on behalf of someone else, okay? And there's a service uses the .NET, it uses the .NET Windows Identity Class constructor. And what I can do is I am sort of sitting there as an application, and provided the constrained delegations enabled, what I can do is say, give me a Kerberos ticket for anyone I like, all right? And I will get it back. And what that was done for was so that, it's an absolute nightmare enumerating someone's group membership. So we can get a Kerberos ticket across, and in the pack, we've got all the group membership. So we can actually truly identify someone. Now, if it's set up correctly, I can use that and I can then impersonate the user. Right? So we can actually do the impersonation. And we can actually get this ticket for two purposes: identity, which in case we just get the ticket back with the identity on it, or we can get it so we can actually not only use identity, but we can do impersonation using that ticket. In terms of constrained delegation, coming in at the front end, other protocols can be used. Right? So Maria can come in and we could, the ticket itself is not marked as forwardable anymore. Right? So if we could actually have this ticket set up so it's not forwardable, Maria comes in at the front end, and depending on how that account's set up, we could actually go and get Maria's identity, or we could get someone else's identity completely. All right? Maria could come in using NTLM, and we can transition because we can request a Kerberos ticket on behalf of Maria and transition to the back end. But the best way is actually to see this in operation. And let me actually go up and set up constrained delegation. So I'm just going to go back to my web server and go to Web 1 this time. Sorry, go to the domain controller first of all, and to Web 1, properties, and we go to delegation, and here we're going to go trust this user for delegation to Pacific Surface. If I use Kerberos only, what's going to happen is it will have to be Kerberos in at the front end. If I say use any authentication protocol, I can come in with anything I like at the front end. So I'm going to actually do that, but before I do that, I'm not going to do it on this account. What I'm actually going to do is I'm actually going to use a different application that I've got. And let's actually look at this different application, first of all. So I'm going to go back to my client over here, and I'm going to fire up a new application, which is called Transition. And it's identified that we're Maria, right? Impersonate to local resource, absolutely fine, right? Impersonate to remote resource, and we've actually gone over to the remote resource as well, okay? This is running under the application pool identity of Web 2. Let's actually have a look at that. So this guy over here is running under this, so delegation, the SPN, everything else is set up. And it's saying, trust this user for delegation to Pacific Service only, use any authentication protocol, right? So it's connecting to CIFS on app 2. Right, let's go, and that's the only place it's going to be able to connect. Let's go now to client 2 and connect across here. Here, and we're going to, because we're sellers/Maria, all right, remember client 2 is out in the wild. Sorry, wrong guy. No, I haven't got it set up. All right, well, I'm not going to set that up now because we're beginning to get close to time. I just want to show you one other thing that's really important before we do that. Is what I could do, though, you have to believe me, I could go in with just a straightforward NTLM on here, and it would work perfectly. So I'm just going to go in here, and this is the interesting one here, administrator. I've just decided to be the domain administrator, right? This is running under Web 2 identity, impersonate local resource. Right, something's wrong with the impersonation level. To be able to do that, the application actually has to be trusted to act as part of the operating system. So I'm just going to go over here. I'm going to bring up local security policy in here. User rights, act as part of the operating system. Add in there Web 2. Okay. Need to do an IS reset on there. So what I've done is I've allowed, we've got protocol transitioning, any protocol, right? So any protocol we like. And I've now set up act as part of the operating system. So I go back over to here, to number 1, and we fire up transition. administrator, impersonate the local resource. I've just gained access by impersonating the domain administrator. All right? Impersonate to remote resource on app 2, because I'm running as the administrator. All right, I've got across there because basically I've controlled that access to the share for everyone. Here's the danger. Impersonate to remote resource app 2 $. Okay, so if I'm allowed to act as part of the operating system, I can impersonate anyone I like, right? And I can impersonate anyone I like locally, right? That's not really an issue, because if I've got ACT as part of the operating system, I can hack my way through that box completely. So I own that box, right? The real thing you need to be careful of is if you give your IIS installer administrative rights on that machine, they can act as part of set ACT as part of the operating system on, right? So now we've got it running as part of the operating system, so they can hack anything anyway, right? So that's not a real, it's a security concern if you don't know about it. But that's a possibility. There's nothing special in that code. All I'm doing is requesting the credentials of the administrator. Now, in terms of going out to the other side, right, I've allowed constrained delegation to that box on the CIF service. So I can go out as the administrator. If I want to stop going out as the administrator, what have I got to do? Mark the administrator's account as sensitive, in which case I will not be able to delegate out using that account. Right? And that is, to say, the real potential gotcha with this. If you allow constrained delegation with protocol transitioning, and the web service is running acting as part of the operating system, you have potentially got a big security hole that you need to think about very, very carefully indeed. So, in fact, whoops, I've gone the wrong way, that's why. So it's the security concerns I wanted to bring. Whoops, sorry, I'm switched back. So just bear that in mind when you're thinking about it. And so, when you're going through the whole process, just take the whole thing slowly, troubleshoot it, all right, let's say, troubleshoot all the way with actually doing your auditing, and you must create a test environment, set up your SPNs, etc. Kerberos tickets, very good way of troubleshooting, looking at those flags, monitoring the network, and auditing resource access. But please, please, please be aware that if you've got transitioning on and you've got ACT as part of the operating system, you have potentially opened up a lot of holes. And what you've got to realize is that application can go out somewhere else as anyone. So we've got to restrict which servers it can get on and which services it can get on. So be very careful when setting in where you're allowed to transition to, or sorry, where you're allowed to delegate to. So keep your constraints in there very tight and mark accounts as sensitive. If you've got any questions, by all means, come down afterwards. Otherwise, have a fantastic trip home when you go. And please don't forget to fill in your evaluations. They're very important. Thank you very much indeed.